Yeah. A squared plus.
We know it's 2a.
Minus.
Okay, did you finish?
Okay, that's like really.
What's the danger with number one? Yes,
The danger. Right, what some people do is they only apply it. They would do like a squared plus b squared and just keep that as the answer. I think.
nice. Yeah, that is the danger. If your answer is a squared plus b squared, you may have forgotten something. You can't distribute exponents. So what do we do? Yes, Karen.
Right, that is a plus b times a plus b, so you get a squared plus ab plus b squared.
You get one?
A squared plus ab plus b squared.
I'm with you on the a squared, the first term and the last term, but that middle term needs, what number does that middle term need? It needs a 2, doesn't it? 2ab. Now, some of you may use a property that is a 4-letter F word to do that problem. I just like to call it the distributive property. Do you know what I'm talking about, the 4-letter F word? We don't say that. I use dirty students.
Wait, what's the word?
I don't say those, but it rhymes with spoil.
Wait, why can't you foil that? Wait, no, like, wait, what is foiling mean?
Exactly, what does it mean? It's just distributive property. It's just distributive. So that's what I use. So it is more of a mouthful, I understand, but we use distributive property to go from that second step to the third step, or second line to the third line. If you want to use that word on your own time, that's you. But it's a slippery slope to prison. You already know, and have you memorized that form, by the way? Not even using distributive property, but know that that is a fact. We're gonna be using that a lot this year. I'll get to that a little bit later, but I need you to not use that F word or not use the distributive property. Just know as a fact that a plus b quantity squared is equal to a squared plus 2ab b squared. But that's the thing for another day. A plus b times a minus b. Would you please show me how many terms are left when you finish distributing? Nice. You guys have 2 on the count of 3. Let's hear it. We have 1, 2, 3.
A squared minus.
Are you like in a choir or something? Right? That was beautiful. I heard some baritone.
Who's Taurus?
Nice.
Not you.
Yeah, a squared minus b squared, which is what kind of, would you just check with your neighbor? What special expression is this called? Your math teacher must have referred to this as something. Please check with your partner. Yeah, I'm hearing it. Difference of squares.
Mr. sung it. Yeah. And then talk about his turtle running away or his.
Oh my god, no.
Oh, Mr. Reeves had a song about the difference of squares? Is it true? Yes. Okay, so today, before we do the actual work of the day, would you just check in with your neighbor about the date and see if they have any idea what that means and how that applies to today's test?
So. It says that's what 4 times.
Yes. Yeah.
Yeah, does anyone know how to say this? I don't know if you've done anything like this in one of your classes. Maybe this is new, but maybe you figured it out because you know, of course, the answer is 3. But how would you go from that 81 to 3? Any idea? No, it's not a square root is the thing. It is it's a 4th root. which means
What is?
what times itself 4 times is equal to 81. And of course, the answer for that one is like 3 times 3 times 3 times 3. Is that true? That's 81.
Yeah.
Yeah, that's 80. So just a foreshadowing of what we're doing today. Yes,
That's a new. That's a new.
that's a new.
Number like 3, 5, 6. Like
Yeah. Yeah. But cube root, fifth root, 12th root. Who knows what's coming your way? We'll see. Yeah. Lots to look forward to in your young lives. Principal square roots. Every number has how many square roots? I'm going to say I'm sorry, I had to adjust this. Every positive number has how many square roots? Just one? Has 2, doesn't it? Like negative and positive. Has 2 square roots. When you see this radical, this refers to only the positive one. And that positive one is called the principal square root or the principal root. Yeah. So when you see like A, you see that square root of 81, we know that the answer is 9. I know some people may argue, but isn't the answer also negative 9? Well, that's answering a different question. If I'm asking x squared equals 81, then yes, there are 2 different answers for that, either positive or negative 9. But if I'm just looking at that radical, all I want, and I'll put that as a note up here, that is plus or minus 9. But that square root of 81, we're just talking about the positive square root. For B, any idea what that is? That one is negative 7. It's kind of order of operations there. I'm going to let you go from C through H. So I'll let you do the rest and see how it goes. And when you're done with stock, check in with your neighbor. I feel like you could probably get through most of these. There's one I suspect that's getting wrong, if any. Like for C, I think you said that 6 plus 8 is equal to 14. Did you do something like that? Yeah. For D, did you also make that 6 plus 8? No, it can't be split up. 36 plus 64 to get that 100, and you know square root of 100 is 10. Square root of 6 squared is 6. Did I actually have to make it a 36 and then go down to 6? Or that square root kind of just cancels. So if you see something like the square root of 17 squared, hope you're not going to try to square that 17 and then bring it down. It kind of cancels. And F, the answer is 6. So it doesn't cancel if there's a negative in there. The output of a square root has to be positive. So our answer there is 6.
Output. Is that, what do you mean by that?
Means the answer can't be -6, right? So this is our input was this, and when we do the problem, that's kind of the output of the problem. The answer can't be negative. We're looking at the principal square root. So it's positive. Now, how did it go from -6 to +6? When you square that negative, it becomes positive 36. Square root of 36 is 6. Yes.
So -6, square root of that, what would the answer be?
-6 and the square root of what?
Square root of -6.
What is the square root of -6? What kind of number is that? It's imaginary. We're not dealing with that just yet. Well, a good question. In general, we don't want to keep negatives inside the square roots. And we won't this chapter for sure. G. On the count of 3, 1, 2, 3. 10. Do we need to show work for that? No. H. Did you already finish H? We're good with 10√5? Just to make sure we're okay with that, we break up that 500 into 5 times 100, because we don't know the square root of 500, so you have to find the largest perfect square possible. We know the square root of 100, like you said, is 10. The way I think about it is that perfect squares get out. Non-perfect squares remain. Of course, that's just storytelling. Really, it's just a property. It's just saying square root of 5 times square root of 100 is 10 times square root of 5. Easy. Okay, going up here, the square root of a squared. I don't know why there's a dot there. The square root of a squared is equal to, it's not a. We have to make sure it's positive, right? And a could be either positive or negative. How do you make sure that something is positive? Math? Absolute value. So if you're not sure if that variable is positive or negative, we just have to make sure that the output is positive, and we do that, those pretty absolute value signs. So that was some missing information before this, this right here. This applied directly to this. So technically, if you really want to show all your work and be amazing, this would be equal to this, and then that's equal to 6. I would never even take off points, of course, for skipping this middle step. Or if you don't even want to think about it, that's fine. But that's kind of how it relates to the property I just talked about. No matter what's inside, if it's positive or negative, the output is positive in a square root. Product and quotient rule for square roots. Okay. Square root of AB is equal to square root of A times the square root of B. Square root of A over B is equal to square root of A over square root of B. I'm going to zip through as much of this as I can to get you to the assignment portion of the class. Try to work on that in class. But if something is unclear, please let me know. So, A square root of 6x times square root of 3x. I'm going to use the product property of radical backwards. Make this square root of 18x squared. Would you please simplify that? Check with your neighbor. Did you remember to put it? Did you remember to put it? You know what I'm talking about? Do you remember to put it? So 3 comes out, doesn't it? What happens with that x squared? Absolute value of x times the square root of 2. What do you think?
Why do we have to absolute?
Yes.
Can you put the absolute value instead of just around the variable around the whole thing? Or does it just have to be around the?
Well, 3 is already positive. There's no question about it. So no need to put it there. It wouldn't be wrong to do that, but it would not be as simple. But the question is, why are we doing that? It comes back to the property of square root of an unknown squared is equal to the absolute value of that unknown. So since we have square root of x squared, it's appropriate to make sure that it is positive coming out of that. Now, if the problem says that the variable is positive, do you need to say absolute value? No. If it said, what's another way to say positive? Do you know? Non-negative. But zero is kind of iffy territory. So if it says the variable is non-negative, also you do not need to put those absolute values. So hard to confuse things. There is an argument to be said because this problem started the way it did. It's appropriate to assume that the variable is already positive. Does that make sense? That we could already assume that the variable is positive from here because of what? It's inside the radicals. And as I just said, we're not dealing with what kind of number is it when you have negative inside the radical? We're not dealing with imaginary numbers. So we can assume from the beginning that they're already positive. So it's not entirely necessary to have this, but it's not wrong to have it. I'm gonna have you finish this set, B through E. Check in with your neighbor when you are done or stuck with this set. Everybody can just make sure that your neighbor's getting the same answers you got.
Same as.
I was like, one big group needs to be science guys. This big group, one big group.
You ready? Ready now? B, what'd you get? 5x root 2. Are we good with that? If we put on the absolute value, that'd be great. C, 10/3. D, what's a good first step? Yeah, let's just put that over everything and simplify that radical. Simplify the fractions. We know that 6 goes into 8. What, 8 times, is that right? And then x cubed divided by x is x squared. And then this simplifies to 2x root 2. Do we know that x is negative? Or do we know that x is positive?
Yes.
Yeah, in the numerator or in the denominator, we see it's 6x. It's got to be negative in there. In the numerator 2 is x cubed, but if you put that absolute value, it wouldn't be wrong. For E, who likes to tell us what they got? Someone hasn't given an answer yet? At least what'd you get?
5x y squared and then root 3x in there, but I couldn't decide whether or not the x should be
Root what? I'm sorry.
3c cubed.
Okay, like that? You can decide if, okay, well, where did the y squared come from? So you simplified this, you got square root of y to the fourth, right? And then that's y squared. Are we good with that being y squared? Okay. Yeah, so then the z, what do we do now with that square root of z cubed? Yes, Ben?
We see. Z.
To the,
No, Z and then rise.
does that make sense?
That means so.
Because it's Z squared times Z.
Yeah, it's nicely said. Z cubed is z squared times z, and for when you're simplifying square roots, we're looking for perfect squares. So that just becomes z root to z. Of course, I have to put that all together. That's just a little bit of side work. So 5xy squared z times the square root of 3. Yes,
Why would it put them in output value?
you could. You
Wait,
could.
wait, 3z, right?
For z, yeah.
3z?
3z. Thank you. I forgot z. Good catch. Nice.
There should be enough to values, like.
Well, let's see. Is it possible
Not
that
the Y squared, but the X.
is it possible that x's are negative? If x were negative, we deal with an imaginary number down here. So x's aren't negative, so we don't need to round x's. It's possible that the y's are negative. It might be negative. And then raised to 6, yeah, that's fine. So it could be negative, could be negative.
Okay, why for that, why can't the X be negative again?
If x is negative, 2 times a negative number times y it's going to give us a negative number inside the radical. And we don't deal with that kind of situation. So we can assume, probably set up that x is not negative. But y's could be negative.
X squared.
But in the end, you're squaring that negativity. So this is no matter what, positive already. And so some deep analysis here. One moment. And let's just look at the z's. It's possible that z's are negative.
And in the.
Z cubed would leave us with a negative number in there. So if we can assume that z is not negative. So it would be appropriate to leave them off completely. If you want to be safe, this is not wrong. It's fine to just put absolute value around everything. Yes.
Because will you be looking for absolute values?
Good question. I'm looking for correctness. So as long as it's correct, you're good. So if I ask this, if this is a question on the quiz and you write X, is that correct? It could be, but X could be negative. So in this case, we'd have to put the absolute value around it. The problem is all of these are really annoying because it comes from square root of X times square root of X, which does equal this. But there's no chance that X is negative in this case. So this is a little bit of analysis. Now, one thing about this class, and you're going to see this more and more, is the answers aren't always clear cut. Like arithmetic, the answers were always like 5 plus 7 is always going to be 12. There's no day where that doesn't happen. But there, like when I say square root of X squared is equal to the absolute value of X, yeah, sometimes that's true. But if this comes from this, it's unnecessary to put those absolute values. So it takes a little deeper level of thinking. I give you just a moment to talk that out, see if you could digest it a little bit, and we're going to move on with today's stuff. I'll leave this up if you like.
You put absolute values on something, like just to be safe on the quiz, but like maybe it's not needed, so we get subtracted points off.
I won't take out points for value.
Or not having absolute values.
For having absolute value. I won't take points off.
You could, but not.
It's incorrect. Yeah.
That's absolute value. You know?
Okay. Let us move on. I'm gonna erase some of this stuff over here. I know it's not fair that I have more room on my notes than you do. That's the way it goes. Okay, if we have something like I don't know, 4x plus 3x, you know that's equal to 7x. And in the same vein, 4 root 5 plus 3 root 5 is equal to 7 root 5. Does this seem familiar to you? You comfortable? Is it adding like terms? Is that what they call it? Like radicals? I don't know. Just you could add like stuff. So A, are these like? Well, I'll give you a chance to look over it because I think there's kind of a deeper level. So they can be dun dun dun. Go ahead and work through A when you're done or when you're stuck. Check out your neighbor. Yes.
I got 17. I did this. I like. I know, okay. I was like, there's like a 3 in both, right? And it'd be like 9 times 3. Right? And I just. Me outside.
We all get A and B.
I went to the end.
You work on A and B. I'll be calling 2 people to help us out with these.
Yes, I feel that's not. It's okay. Wait.
Maybe it's like a. I'm just gonna do 2.
Yeah, okay. But it's 32, that's 2,000.
Right?
Okay. Before I ask someone to help me with this, my question is, what's happening with this 5 and the square root of 27? Are they just hanging out, or is there something happening to them, or they're being multiplied? How did you know that?
It's usually if you switch terms that it can next to each other, the assumption is then multiplied, like you have A times B.
Did you all hear that? Does that make sense? I love your example. If you see AB, that's not like a word. Well, it is a word, but it's in math, it's not a word. It means A times B. You're not like, you're not working on your abs. It's multiplication. So this is 5 times the square root of 27. So with that in mind, you can help us with A. And I want you to talk it out. Yes, Holland.
So what I did is that square root of 27, I split up into 9 times 3. And then we know the square root of 9 is 3 times the 5 is 15 root 3. And then I did the same thing.
Just a minute. Are you sure it becomes 15? Absolutely.
Yes.
Are we good with that 15? Right, it's all multiplication right there. So yeah, 15. And I'm sorry to stop you. Keep on going.
And for the 12, I split it up into 4 times 3. And then that becomes 2 root 3. And you add those and it's 17 root 3.
Are we good? Nicely done. Now this 9 times 3, can I just put a 9 and a 3 in there and just assume it's multiplication? I don't think it works like that, does it? It only works when you have like a number and a letter or 2 letters. But if you have 2 numbers, please put a dot. Should we put an X for multiplication? No, that's old stuff. You don't do that anymore. Who does that? 5th graders, that's it. Okay. Thank you. Someone who hasn't given us an answer yet? B? Yes.
I split up the root 50x into that half of the equation is 4 root 2 and then root 25x or root x. I
I
separated.
said broke up that 50 into 5 and 10. Is that what you did?
I did 2 and 25
2 and 25. Okay.
and then x
Okay.
minus 6 root 16 times 2 times x.
Okay.
And then root 25 is 5, so 4 times 5 is 20, so that makes it 20 root 2x minus 16, root 16 is 4, so 6 times 4 is 24 root 2x. And then that's negative 4 root 2x.
Any questions? Do we need this? Do you need to write that? Maybe in algebra 1 you need to. I'm okay if you skip that. If you skip this and if you skip this, that's purely up to you. That can be work that's done in your head. If you're comfortable with it. Just make sure that you do it right. That's the key. Rationalizing the denominator. Does that bring back good memories? Those 3 words.
So,
I'll take that as a yes. Please discuss with your neighbor. What does that even mean to rationalize a denominator?
Yeah. It's like reduce here, by the top and bottom.
yeah, we did.
Or is it which?
No.
Yeah.
And so,
Rationalizing the denominator means to do what? I don't want to hear the process, but it just means that you need to do something. Get the square root out the denominator. Does that make sense? Do you know why? Why? Why can't you have a radical in the denominator? Because it's irrational.
That's a guess. I don't know. We're rationalizing the denominator, so my guess is we started.
Okay. Right. You start irrational, got to rationalize it. Okay. But what's wrong with having an irrational denominator?
You can't divide something by an irrational.
Why not?
Not because no. It's not rational.
Because it's not rational. Okay, yeah. Yeah. If you go back in time, we recognize this as there's an irrational in the denominator. Now, if you want to get a decimal approximation, all you need to do is type this in your calculator, correct? But back in the day, and if you don't have a calculator, you don't even have a slide rule. Have you seen a slide rule? Slide rule. It's a device they use before calculators. Yeah, things are kind of move. It would be like a ruler, but they're moving parts. You would line things up, and you've seen something like that. And like you would make this a division problem, and automatically you have a problem. Like how many times does square root of 2 go into 1? Well, they knew that square root of 2 is approximately 1.414. But how many times does 1.414 go into 1? It's not quite clear, is it? Or even 10? How many times does it go into 10? So to make the work easier, they rationalize the denominator by doing what's the top and bottom specifically? Yeah, multiplying top and bottom by this. Now when they go to do the division problem, it's 2 into the square root of 2, which they know again is 1.414 ... You can see it's just easier to come up with a decimal approximation, isn't it? Because that denominator, like you're saying, it's rational. We know how many times 2 goes into something as opposed to 1.414, etc. So it's kind of an homage to the past. It's something that they needed to do just to have decimal approximations. And in our world of everyone has a calculator in their pocket, it's not entirely necessary, except for the fact that math teachers, as you know, we insist on it. It's kind of like grammar. You can make yourself understood without good grammar, or proper grammar, but it's mathematical grammar. So rationalize the denominator. I'm just going to summarize this by No radicals allowed. In denominators. I'll give you a couple minutes. Well, I'll give you like a minute to work through A and B. Don't do C or D yet, please. Just A and B. You done? Okay, for A, someone who hasn't spoken yet? First choice? Yes, Kate. How did you do that?
I multiply the top and bottom by 1, which is like root 3 over.
Oh, that was nicely said. Okay. So on top we get 5 root 3, and on the bottom we get 3. Are we good? And I just love how you said you multiply the fraction by 1. You're keeping the concept forefront. That's great. For B. Yes, Karen.
Great.
Can you tell us how you did that?
I multiplied the numerator and denominator by root 12, which is 2. So, that 6 becomes a 12 with the root 3. We multiply by it, and then to give the 12 in the denominator, and so the 12 and the 12 cancel each other out. So you end up with just root 3 over 1, which is just root 3.
Okay. So I was trying to follow your work, and I did something like this because you said square root of 12 is 2 or 3. So maybe on the top you did this, and the bottom you did this. Would you be comfortable doing that? This seems like next level thinking to me. I love it. Just be careful. Make sure you're doing the same thing top and bottom. Yeah, bottom is 12, top is 12 root 3. Lovely. Did anyone do B a different way? Yes, or do you have some input or yes?
Oh, I just did it. I simplified the root 12, like 2 root 3 at the bottom, and then I just did root 3 on the top. And yeah.
So from here you got 6 root 3 over 2 times 3, 6, like that. What do you think? Which way is right? They're both right. That's why I ended up in the same place. Thank you for sharing that with us. Okay, for C, before you write anything, would you just check in with your neighbor to see if you remember what to do here, how to rationalize it?
Yes, I learned root 3.
Yeah.
Okay. Do you remember? Okay, so what's the problem with doing this? Because some people do this.
Yeah, about 5.
Yeah, on the bottom, you have to distribute it. That's still a problem, isn't it? Some people multiply top and bottom by 5 plus root 3.
That doesn't.
Well, I get a difference. Right?
Yeah, and the bottom, if you do this, you're going to have a middle term, aren't you? That's that 2ab that we're talking about in the warm-up. So we have to multiply top and bottom by 5 minus root 3. Does that sound familiar? Wow, you retain so much. It's amazing. So top, I think we have to distribute 35 minus 7 root 3. Bottom, should we distribute, or do we already know the answer? It's just a squared minus b squared. We're multiplying two quantities, the results of whom are a difference of squares. So it's just 5 squared minus root 3 squared. You can distribute if you want, but you're always going to end up back there. And this is what, 25 minus 3? Is that right? 25 minus 3. I think that's 22. 5 minus 7 root 3 over 22. to y'all. Cool. I'll give you a moment to do D. And check in your with the neighbor when you are done or when you're stuck. Bless you. Finished?
Yeah. I just have a.
Your questions? Yes.
Because you said no, there should be like motivators. Like that's. Oh.
4 minus. I just did 5 minus.
I wasn't sure.
So like.
So I think that gets rid of the.
Yeah.
That's. I just heard about. I don't have a message, so. Like here, right? So that's here.
Yeah.
I think you just do like one work steps and make it so that.
Like clusters.
It's like, oh.
Okay, so we're multiplying top and bottom by 5
Minus 4.
-4, 5 -4. Top, 8√5 minus 32. Bottom, we have 5 minus 16. Are we okay with that? First 5 minus 16 is -11. Any questions? Yeah, we don't want that negativity in the denominator. So multiply top and bottom by negative, leaving us with -8√5 plus 32 over 11. Am I done with the problem? Show me a gesture of what would be nice to do. What I'm looking for is this. Do you agree? This would be nice.
Yes.
Just cleaning it up, right? We're tidying it up, this little problem. So the top will become 32 minus 8√5. Now, it's not wrong the other way, and I would never take off points for starting with a negative like this. I may take off, I think I told you, I will take off a point if you're dividing by a negative. Just leave it like that. So please remember to at least do something to bring it to the top. Would it be okay to just do this? Negative 8√5 minus 32 over 11. Is that okay?
You would have to.
It's okay. It's just a little bit scary. Because if you put it here, then it would just be wrong. So my recommendation is be very mindful. If you're going to make the whole fraction negative, that's fine. If you want to apply it to the top, then you have to reverse those two. I think I like the way that we did it originally, so I'm going to stick. It is now at 10:16, at 10:19, I'll resume. Now's a good time for you to zone out, stand up, stretch, chat.
All right. My pleasure.
Yeah. So suffer.
If you have to jump out of my hands. The summer just.
Yeah, we're all.
It's like a better version of the-
Little steps.
I did go. We got this out. We're gonna face it.
Oh,
Summer from last summer.
As long as you're so fast. Yeah.
The air is good. I can't. I'm like.
Oh.
I just don't like to.
108, 105.
They
They
look. No, honestly.
Only like 95.
I saw.
Remember the lift?
On.
I know, I don't know why. I need to learn.
Even though you're not.
And the other classes.
You know, well, okay, on my schedule. I'll link everything except.
Hey, can you see this?
Yeah, I'm not even trying.
I don't know.
You want to like talk me through, but that's.
But like my.
But we have.
And then.
I'll just wait. I'll probably start.
So with that, I don't even remember. Why? I
Yeah, make it up. Like instead of why can't we just.
Like literally just chords.
Okay, let's continue. Let us continue. Okay. So. I'm gonna cross this out for now. Maybe get back to it. Perfect. Perfect squares. Do we talk about perfect squares specifically last time? Be pleased with your number, your neighbor. Would you please kind of go back and forth and count up as high as you can? Perfect squares, like the first one, of course, is 1, and then just count up perfect squares.
That's 9. Yeah, 16. No.
Yes.
100, 120.
Oh, yeah, I don't know. Yeah, so there's so much. Oh, not 16. 36.
Yeah.
Right? I have no idea. Yeah. Okay, 1, 4, 9, 16, 25, 36, 49.
I'm gonna guess.
60.
No,
So 7, 49.
I got 91. Yeah,
And then 80.
Yeah, that sounds right.
5 more seconds.
121.
Okay, of course, the first one is 1, second one is
4,
4, then 9,
16,
16,
25,
One.
6, 49.
49, 4, 81, 100. Is that all you need? 121, 14. You need more than that? 169. Nice. Do you know that after that? After 169 is
196.
196, then 225.
256.
I do expect you to know all of these so that if you see the square root of 81, I want you to simplify that to 9. If you see the square root of 169, I want you to simplify that to 13. Etc. Is there one before 1? Is 1 really the first one? Is 0 a perfect square?
Zero. But you can't do. Well, 0.
So square root of 0, is that 0?
Yeah.
Generally, we start with 1. In theory, yeah, but like, how's that gonna be helpful? Okay, so we'll start with 1. After 225, are you responsible for knowing any others? Yeah, things like 400. Do you know any others after that? Off the top of your head? Before it?
Oh, yours.
We're all special. 625. If you don't know, I'm gonna leave that off there. I hope you know 10,000. Square root of 10,000 is 100. Yeah, but up to that 225, I do expect you to know them. What's that? 625. Aside from perfect squares, I also expect you to know some perfect cubes. Would you please discuss with your neighbor what perfect cubes do you know? I imagine it's a shorter list.
Eight. 60. Oh. 60.
Okay, so 1. What's the next one? 1, 8, 27, 64. After 64 is 125. I do expect you to know these. After that, it's okay if it's not your fingertips, but I think 216 is next. Is that right? After that, I think it's like 343. After that, something like 512. But I expect you to know up to 125. But that's the good stuff. That's what you need to have right here. Let's keep going. Perfect fourths. Good list and perfect fifths way at it. Fourths. And the first one is 1 for all of them. But let's see if we can figure out what is perfect fourths. How about you?
Oh, yeah.
So like 9 and then multiply that by 2, 18 times. Ah, yes. So after 1 we have, we're doing perfect fourths. 16. Then 81. Anything else? 256. After that, do I expect you to know it? Do you know the next one? Yeah, I don't know. After that, I expect you to know maybe any others? There's one easy one up there. What is it? 1,000? 10,000? I think we know 10,000 would be 10 to the 4th, of course. Yeah, I do expect you to have 116 and 81 at your fingertips. And Kara, I liked what you said, that these could be constructed from, well, these numbers can be constructed from looking at the squares and just squaring them, right? 116, 81, 256, 625. That was really nice. Perfect fifths. We'll start with 1, then go to 32, and that's basically all you really need to know, but let's do one more. $243. That's good to know. Okay.
We expected to know fifths.
Yeah, those 3. Well, at least the first 2. And if you don't know it like this, I expect you to be able to figure it out. They're pretty rare though. And when I say fifths, these are also perfect fifths. Okay, so cube root of 24. Should I break that up into 4 times 6? Please discuss. How do you do this? Instead of 4 and 6, I gotta do 12 times 2, right? That helps. We're looking for perfect cubes. And I just kind of threw in, but I hope we're okay with this being a cube root here. So we're looking for perfect cubes in there. We know that 24 is 8 times 3. So the result here is 2 times the cube root of 3. Is that clear?
Get that accident.
Well, do you know what the cube root of 8 is? Root of 8 is 2, because this comes from 2 cubed. So once we found 24 is 8 times 3, we know that cube root of 8 is 2, 8 outside. We're using that multiplication property, and you're right, I skipped something here. This is a cube root of 8 times a cube root of 3. Cube root of 8 we know is 2, leaving us with the cube root of 3. What do you think? You buy it a little bit? A little bit more sense? Okay. 4 times 10, is that how I should be thinking about this 40? So I'll give you a moment to do the B. Do. Yeah, keep on going. But don't get ahead of your neighbor.
Hey, how's it going? Oh. Yeah,
She combined those. 32. Or put it all under one. Which would be. So they. Okay, so 4.
Maybe.
We know that's 16.
Right, yeah, and then 30.
We know the 16.
Oh, it could be 32.
Now I'm Wait, where? I think that's right. Wait, okay, let's see. It's the same one. So what's So, 4. Wait, what did I just say? Yeah. You can see the inside of the thing here.
So 64, right?
Right.
For this is like this.
Yeah, I got you for that.
Okay.
But I have-
And then this one.
Yeah, all your.
Oh, 4, right? And then this,
One thing I.
because 32 is a perfect fit.
Yeah, I think
It's there. 100%. Wait, these are both. But you have some.
Yeah.
Oh.
Okay, next one. This is a 4. Well, 81 and 16 are. Isn't it just 3 over 2? Okay. Because they're both
Yeah.
perfect.
Take about 30 seconds to do what you can do, then I'm gonna just talk about these pretty quickly. Okay, so ready or not, let's do these one at a time. I'm gonna do these because we're running out of time. I'm sorry, I'd like to get student involvement in general, but we've only so much time today. Now for B, we're hunting perfect cubes. So do you see any perfect cubes in the 40? Yeah, again, there's an 8 in there. So we think about this as 3 times 5, and the 8 gets out, becoming a 2, leaving us with 2 times the cube root of 5. Now C, well, no, so we're no longer looking for cubes, we're looking for perfect fourths. Now that little number that's tucked away is called the index of the radical. So the index has changed to a 4th. We're looking for perfect fourths. I make a quick mental note, and there's definitely no 16 or 81. And you don't have to remove the ones, by the way. 1 is an acceptable perfect fourth to leave. So what am I gonna do with these? Put them together. So we have the fourth root of 32. Is there a perfect fourth inside that 32? 16. Right, that's on our list of perfect fourths. So I'm going to break this up into 16 times 2. We know that the fourth root of 16 is 2. So we're left with 2 times the fourth root of 2. Yeah. Moving on to D. Oh, what's changed here? Index is now of 5. So we're looking at the fifth root of 64. Do I know any perfect fifths aside from 1, of course? 30. And look at that. Is there 32 and a 64? So cleanly. Now, if you want to go right to the end, you can, but I'm going to do this middle work. If you want to go from here to here, you can, once you understand what's going on. For E, what should I do with that 81? Well, show me what the 81 becomes. Becomes a 3, because 81 is a perfect fourth. So think about this as the fourth root of 81 over the fourth root of 16. The top becomes 3. Is 16 a perfect fourth? It is. 2 to the fourth is 16. So 3 halves of what we're left with. And so can you show me the answer for F? Show me the answer with your 2 hands. Looking for 5 over 3 there, 5/3. Did you change 125 over 27 to decimal first? Is that a good way to do this? That'd be a terrible way to do this. Okay, just making sure. Inside that 16, I see there is a 8. Yes, am I missing something?
Question.
Yes.
Do you drop down the 4 or just leave this like 3 over 2 and 5 over 3?
When you say drop down the form, I'm not sure.
If you do 5 to the 4th over 3 to the, or the 3rd, 5.
Good question. Thank you. This breaks down to a smaller question. When it says the fourth root of 81, the question is asking what times itself 4 times is equal to 81. 3 times itself 4 times is equal to 81. So we don't need that fourth anymore. Thank you.
Okay.
Same thing on the bottom. And the same thing here, right? What times itself 3 times is 125. The answer is 5. Just the 5. Thank you again for helping me clear that up. Inside that 16 is an 8. 8 times 2 minus 11 times the cube root of 2. 8 gets out. So the 5 becomes
10.
10 times the cube root of 2 minus 11 times the cube root of 2. Can we add these together? Heck yeah, we can add them together, leaving us with negative cube root of 2. Cube root. Inside that 81, 27. So I'm going to follow that 27. It's going to do what? 27 is going to become a 3, making that 3 a 9. Is that too much done in my head? Did that lose you? If you like, you could do it a step at a time. There's nothing wrong with that. When you go fast, that's when the mistakes start happening. So be careful. Please just go at your pace necessary to you. This is just 3 times the cube root of 27 times the cube root of 3 minus 4 times the cube root of 3. This is me showing every single step. 3 times 3 times the cube root of 3. You show what you need to show to make it right. Then proceed with that answer, which is equal to 5 times the cube root of 3. Are you feeling good? Ish? It sounds like the sound of packing up. Maybe people are just changing pace because we have at least another 8 minutes left. Please discuss with your neighbor what this might mean.
The
I think it's really one house.
Oh my god, I didn't see that.
So like.
A to the A1.
Have you seen anything like that?
I'm gonna take one.
Okay.
Yeah. Okay.
Okay, so I'm gonna ask that discussion come to an end. Now, let's say we have no idea what this is, so I'm gonna play with it a little bit by multiplying it by itself. 16 to the 1/2 times 16 to the 1/2 is equal to 16, isn't it? Now, I didn't know what 16 to the 1/2 is and 16 to the 1/2, but I know that they're equivalent to each other. So what times itself is equal to 16? What number times itself is equal to 16? 4. So 16 to the 1/2 is equal to 4? This is another way of saying square root of 16. Right, this is the same thing as saying square root of 16 times the square root of 16 of 8 to the 1n. N becomes the index of our radical.
What if the numerator isn't?
Good question. We're gonna do that next. You're like a soothsayer sorts. Foretelling the future. Okay, so 64 to the 1/2 means the same thing as. Have you seen this? Those of you with iPhones, have you noticed on that scientific version that square root is represented with the little 2? Did you ever notice that? It has a little 2 in it for some reason. But standard, if it's empty, we would just say square root of 64 is equal to 8. We don't normally put that 2 in the index. So B, that's just read. Well, it's 125 to the 1/3, which is the same thing as the cube root of 125. Which we know is, of course, 5. That's it's on our list. C. Wee bit tricky.
Take the negative and the outside.
Yeah, that negative is not involved with this situation. 81 to the 1/4 is the exact same thing as saying the 4th root of 81. Do we know what the 4th root of 81 is? 4th root of 81 is 3, and then we tack on that negative.
Can we do D?
Is D even possible?
Yes, I know.
According to this, I can't take out that negative, so I have the cube root of -8. Is that possible? Remember, cube root is different from square root. We're looking for something times itself 3 times.
-2 is -8.
It is -8. So do we have an answer here? It's -2. Mind blown. So no negatives in the square roots, but in time a cube root is fine. And 27, is that a -1/3 that I see?
Was it?
Oh, yeah.
It is. Are you able to see that in your work, like in your packets?
It's really hard to. It means.
Yeah, that's definitely poor formatting, but that's a negative one. Yeah. So this is equal to 1/27 to the 1/3, which we know is
3.
well, 27 to the 1/3 is 3. That's why our answer is. I'm gonna do the intermediary steps of 1/3.
No.
Any questions? Yes.
Is it possible that that 1 could be like a 2 or 3, like if you had 27 to the -2/3?
We're supposed to do that today, right? We're like something else over N. But I feel like there's very little time left and I don't want to do a bad job. So I want to do this next time. If you see something like this in your homework, please skip it and get back to it next time. For right now, I want you to just discuss with the neighbor what are the salient points of today. What did we talk about that are good for you to keep in your head? And then I'll get questions on your way out.
How does this get the problem?
Click on the next.
You just want to give you like the work with that way for us.
You'll be able to fill it in.
Wait,
No.
Yeah, I'll change. They'll give us-
I don't even remember.
So is this gonna be on the quiz?
I won't put that on the quiz.
Wait, when is our quiz next?
Yeah, the fifth. It's next. Oh,
Okay, so what are the points from there?
We've got rationalizing.
Perfect.
not for quizzes. Just homework.
Adding distraction square.
And then the. Over. Is the.